So this one is problem number 35. So to factor this, first thing I notice, what do you guys notice about all three terms? They're all divisible by 3. So I'm going to factor out a 3, which gives me 5k squared minus 4k minus 1. Okay? Pun intended. So now the 3 just kind of stays out to the front, but to solve the stuff in the parentheses, remember I just put the first term in the first box and the last term in the last box. So I'm going to say 5k squared and then negative 1 here. Now 5 is a prime number, so the only way I can get that is 5k times 1k. That's the only way I can get 5k squared. So now I need to think, I'm going to put a number here and a number here that gives me negative 1. Well, one of these has to be positive and one of these have to be negative. But it's 1 times 1. So now if I put a negative in here, I get a negative 1k plus a positive 5k. But if I put the negative here, I get a negative 5k plus 1k, which gives me a negative 4k. So remember that these two boxes have to add up to this middle term. So I'm going to make this one negative and this one positive. When I do that, 1 times 1k is just a positive 1k. And then 5k times negative 1 is a negative 5k. So what's negative 5k plus 1k? Negative 4k. So then that means that 3 times this stuff is just 5k plus 1 times the quantity k minus 1. Is that D? And as always, if I wasn't 100% sure, what I could do is just graph it in Desmos. So if I go to Desmos, what do you mean, Mr. Adams? Well, graph your answer, 3 times the quantity. You have to use x though, 5x plus 1 times the quantity x minus 1. Okay, that's that graph, right? We'll zoom in on it a little bit. Check that bad boy out. And the original equation, which is 15x squared instead of k, right? Minus 12x instead of k minus 3. They're the exact same, aren't they? Think this is a game? You think I'm playing around? I don't know why you came to school today. I came to do math. It's an M for million.